A sawmill is generally considered a Class 3 location. This classification stems from electrical codes and standards that recognize the inherent hazards associated with the accumulation of combustible dust, specifically wood dust in this context. Class 3 locations are defined as areas where easily ignitable fibers or materials producing combustible flames are handled, manufactured, or used. The presence of wood dust in a sawmill environment creates a risk of fire or explosion if ignited by electrical equipment or other sources of ignition. However, not all wood processing plants are automatically classified as Class 3 locations. Several factors can influence the classification of a specific area within a wood processing facility. Examples of wood processing plants or areas within plants that may not be classified as Class 3 locations include offices and administrative areas. These are areas where there is no significant accumulation of wood dust or fibers. Areas such as offices, conference rooms, and reception areas are typically free from the hazards associated with combustible dust. Secondly, storage areas with limited wood dust, such as warehouses or storage sheds, where wood dust is minimal and not likely to create a hazardous atmosphere, may not be classified as Class 3. The key factor is the potential for dust to accumulate and create a fire or explosion hazard. Thirdly, woodworking shops with dust collection systems may not be classified as Class 3. Small woodworking shops or classrooms that have effective dust collection systems that prevent the accumulation of airborne dust are examples of this. These systems capture dust at the source, minimizing the risk of it becoming a hazard. Furthermore, sawmills with spark extinguishing systems may not be classified as Class 3. Sawmills that have installed approved spark extinguishing systems on all operating machinery significantly reduce the risk of sparks igniting wood dust. Spark extinguishing systems are designed to detect and suppress sparks before they can ignite combustible materials. It is important to emphasize that the classification of a wood processing plant as a Class 3 location or otherwise depends on the specific conditions and operations of the facility. Several factors must be considered when determining the appropriate classification. One such factor is the type and amount of wood being processed. Different types of wood produce varying amounts of dust, and the quantity of dust generated can impact the classification. Another factor is the effectiveness of dust control measures. The presence and efficiency of dust collection systems, ventilation, and cleaning practices play a crucial role in mitigating dust hazards. The presence of potential ignition sources is another important factor. Electrical equipment, machinery, and other potential sources of ignition must be evaluated to determine the risk of igniting combustible dust. The applicable electrical codes and standards must also be considered. These codes provide specific requirements for electrical equipment and wiring in hazardous locations, including Class 3 locations. It is strongly recommended to consult with an electrical engineer or qualified electrician to determine the appropriate location classification for a particular plant. These professionals have the expertise to assess the specific conditions and operations of the facility and apply the relevant codes and standards. They can also provide guidance on implementing appropriate safety measures to mitigate the risks associated with combustible dust. In summary, while sawmills are generally considered Class 3 locations, some wood processing plants or areas within plants may not be classified as such. The classification depends on factors such as the presence of dust, the effectiveness of dust control measures, and the presence of ignition sources. Consulting with a qualified professional is essential to ensure accurate classification and implementation of appropriate safety measures. The National Electrical Code, or NEC, provides guidelines for electrical installations in hazardous locations, including those with combustible dust. Specifically, Article 500 and subsequent articles address the requirements for Class 3 locations. These requirements cover aspects such as wiring methods, equipment selection, and grounding. The NEC defines Class 3 locations as those where easily ignitable fibers or materials producing combustible flames are handled, manufactured, or used, but the quantities of such fibers or flames are not likely to be in suspension in the air in sufficient quantity to produce ignitable mixtures. This distinction is important because it differentiates Class 3 locations from Class 1 and Class 2 locations, which involve flammable gases, vapors, and combustible dust suspended in the air, respectively. In Class 3 locations, the risk is primarily from the accumulation of fibers or flames on surfaces, where they can be ignited by heat, sparks, or other sources of ignition. Therefore, the NEC requirements for Class 3 locations focus on preventing the accumulation of these materials and minimizing the risk of ignition. One of the key requirements for Class 3 locations is the use of dust ignition-proof equipment. This type of equipment is designed to prevent the ingress of dust and to contain any internal explosions that may occur due to the presence of combustible dust. Dust ignition-proof equipment is typically enclosed in a robust housing with tight-fitting covers and seals. Another important requirement is the proper sealing of conduit and fittings. This prevents dust from entering the electrical system and creating a potential ignition hazard. The NEC also specifies requirements for wiring methods in Class 3 locations. Wiring must be installed in a manner that minimizes the accumulation of dust and prevents it from entering the conductors. Surface wiring is often preferred over concealed wiring, as it allows for easier inspection and cleaning. Grounding is another critical aspect of electrical safety in Class 3 locations. Proper grounding helps to prevent the buildup of static electricity, which can be a source of ignition for combustible dust. The NEC provides specific requirements for grounding electrical equipment and systems in hazardous locations. In addition to the NEC requirements, other standards and guidelines may also apply to wood processing plants. These may include standards from organizations such as the National Fire Protection Association, or NFPA, and the Occupational Safety and Health Administration, or OSHA. The NFPA develops standards for fire prevention and electrical safety, while OSHA enforces workplace safety regulations. These standards and regulations may address aspects such as dust control, ventilation, and housekeeping. Effective dust control is essential for minimizing the risk of fire or explosion in Class 3 locations. Dust control measures may include the use of dust collection systems, ventilation, and regular cleaning. Dust collection systems are designed to capture dust at the source, preventing it from becoming airborne and accumulating on surfaces. Ventilation helps to remove dust from the air and maintain a safe working environment. Regular cleaning is necessary to remove accumulated dust from surfaces and prevent it from becoming a fire hazard. Good housekeeping practices are also important for maintaining a safe working environment. This includes keeping work areas clean and free from clutter, storing combustible materials properly, and regularly inspecting and maintaining equipment. In addition to these measures, employee training is essential for ensuring that workers understand the hazards associated with combustible dust and how to prevent them. Training should cover topics such as dust control procedures, emergency response procedures, and the proper use of equipment. It is important to note that the classification of a location as Class 3 or otherwise is not always straightforward. The specific conditions and operations of the facility must be carefully evaluated to determine the appropriate classification. Consulting with an electrical engineer or qualified electrician is essential for ensuring accurate classification and implementation of appropriate safety measures. These professionals have the expertise to assess the specific conditions and operations of the facility and apply the relevant codes and standards. They can also provide guidance on implementing appropriate safety measures to mitigate the risks associated with combustible dust. The determination of whether a sawmill or any wood processing plant is considered a Class 3 location depends on a thorough assessment of several factors. Firstly, the presence and concentration of combustible dust are paramount. Class 3 locations, as defined by the National Electrical Code, are areas where easily ignitable fibers or materials producing combustible flames are handled, manufactured, or used. However, the key distinction is that these fibers or flames are not likely to be suspended in the air in sufficient quantities to produce ignitable mixtures. Instead, the hazard arises from the accumulation of these materials on surfaces where they can be ignited. Secondly, the effectiveness of dust control measures plays a critical role. If a wood processing plant implements robust dust collection systems, ventilation, and cleaning practices that effectively minimize the accumulation of dust, the likelihood of the area being classified as Class 3 may decrease. Dust collection systems capture dust at its source, preventing it from becoming airborne and settling on surfaces. Ventilation systems remove dust from the air, reducing its concentration. Regular cleaning removes accumulated dust, preventing it from becoming a fire hazard. Thirdly, the presence of potential ignition sources is a significant consideration. Electrical equipment, machinery, and other potential sources of ignition must be evaluated to determine the risk of igniting combustible dust. Equipment used in areas with combustible dust should be specifically designed and certified for such environments. This includes dust ignition-proof equipment, which prevents the ingress of dust and contains any internal explosions. Fourthly, compliance with applicable electrical codes and standards is essential. The National Electrical Code, NFPA standards, and OSHA regulations provide specific requirements for electrical installations in hazardous locations, including Class 3 locations. These requirements cover aspects such as wiring methods, equipment selection, and grounding. Fifthly, the specific activities and processes conducted within the plant influence the classification. Areas where wood is actively being cut, sanded, or otherwise processed are more likely to generate significant amounts of dust and thus be classified as Class 3. In contrast, areas such as offices, conference rooms, and break rooms, where wood processing activities are minimal, may not be classified as Class 3. Sixthly, the physical layout of the plant impacts the classification. Areas that are enclosed or poorly ventilated are more likely to accumulate dust and be classified as Class 3. Open areas with good ventilation may be less likely to be classified as such. Seventhly, the type of wood being processed can affect the classification. Certain types of wood may produce more dust than others, increasing the risk of fire or explosion. Eighthly, the frequency and thoroughness of housekeeping practices are crucial. Regular cleaning and removal of accumulated dust can significantly reduce the risk of fire or explosion. Ninthly, the implementation of spark extinguishing systems can reduce the risk of sparks igniting wood dust. These systems detect and suppress sparks before they can ignite combustible materials. Finally, documentation and record keeping are important for demonstrating compliance with safety standards. This includes maintaining records of dust control measures, equipment inspections, and employee training. Given these factors, it is crucial to consult with a qualified electrical engineer or safety professional to conduct a thorough assessment of the specific conditions and operations of the wood processing plant. This assessment should consider all relevant factors and ensure compliance with applicable codes and standards. The engineer or safety professional can then provide a recommendation regarding the appropriate classification of the plant and any necessary safety measures. Wood dust is a significant fire and explosion hazard in wood processing facilities. It is a fine particulate matter generated during various woodworking operations such as sawing, sanding, and machining. The composition of wood dust varies depending on the type of wood being processed, but it generally consists of cellulose, lignin, and other organic compounds. Wood dust is highly combustible, meaning it can easily ignite and burn rapidly. When suspended in air in sufficient concentrations, it can form an explosive mixture. The explosivity of wood dust is influenced by several factors, including particle size, moisture content, and concentration. Finer particles are more easily ignited and burn more rapidly than larger particles. Higher moisture content reduces the explosivity of wood dust, while low moisture content increases it. The minimum explosible concentration, or MEC, is the lowest concentration of wood dust in air that can support an explosion. The MEC for wood dust typically ranges from 30 to 50 grams per cubic meter. Several factors can contribute to the ignition of wood dust. These include open flames, sparks, hot surfaces, and static electricity. The electrical equipment that is not properly designed and maintained can also be a source of ignition. To prevent fires and explosions in wood processing facilities, it is essential to implement effective dust control measures. These measures should focus on preventing the accumulation of wood dust and minimizing the risk of ignition. Dust collection systems are a primary means of controlling wood dust. These systems capture dust at its source, preventing it from becoming airborne and settling on surfaces. Dust collectors typically consist of a hood or enclosure to capture the dust, a duct system to transport the dust, a filter to remove the dust from the air, and a fan to create airflow. The type of dust collector used depends on the specific application and the amount of dust being generated. Baghouse collectors are commonly used for high-volume dust collection, while cartridge collectors are suitable for smaller applications. Cyclone separators are often used as pre-filters to remove larger particles from the air before it enters the main dust collector. Ventilation is another important dust control measure. Ventilation systems remove dust from the air and maintain a safe working environment. General ventilation systems provide a general dilution of dust in the air, while local exhaust ventilation systems capture dust at its source. Local exhaust ventilation systems are more effective at controlling dust than general ventilation systems. Regular cleaning is essential for removing accumulated dust from surfaces. Dust should be removed using vacuum cleaners or other methods that do not create airborne dust. Compressed air should not be used to clean surfaces, as this can create a dust cloud that can be easily ignited. Housekeeping practices are also important for preventing the accumulation of wood dust. Work areas should be kept clean and free from clutter. Combustible material should be stored properly. Equipment should be regularly inspected and maintained. Employee training is essential for ensuring that workers understand the hazards associated with wood dust and how to prevent them. Training should cover topics such as dust control procedures, emergency response procedures, and the proper use of equipment. In addition to these measures, spark extinguishing systems can be used to reduce the risk of sparks igniting wood dust. These systems detect and suppress sparks before they can ignite combustible materials. Spark detectors are typically installed in the ductwork of dust collection systems. When a spark is detected, the system automatically activates a water spray or other extinguishing agent to suppress the spark. Combustible dust pose a significant hazard in various industries, including wood processing, agriculture, and chemical manufacturing. Understanding the properties of combustible dusts and implementing effective control measures is essential for preventing fires and explosions.